Hi folks, welcome to the third video in 8.8 vectors. And in this video, we're going to talk about magnitude and direction of a vector. So let's get started. The magnitude of a vector, all right, we've been using this word a lot, but the magnitude of the vector is basically just how long the vector is. And we can use the Pythagorean theorem to find it, okay? Now, the direction of the vector, we can find that using inverse tangent. Now, if this feels a little familiar, like maybe similar to polar coordinates and how we find our r and theta, it is exactly like that, okay? So if you've been sitting here thinking, oh, this feels like polar conversions with the r comma theta, it is exactly the same formulas, okay? So our r, our radius, is really the magnitude of the vector, and the direction is given by the inverse tangent of our rectangular coordinates, okay? Now, the last new vocabulary I want to introduce here is the component form of a vector. And so one of the powerful things about a vector, kind of like parametric equations, is we can break it up into what we call the components, or really the horizontal piece and the vertical piece, okay? And the horizontal piece, let's do a little color coding here. The horizontal piece, not surprisingly, deals with cosine. All right, so we think about our unit circle, how all the x values on the unit circle tell us the cosine of the angle. And hopefully, not surprisingly, the vertical piece deals with sine. Okay, and so we can take the magnitude times cosine theta and the magnitude times sine theta to give us the standard form. So let's go ahead and put that vocabulary again down here, standard form. And then we can take the cosine and the sine and include this I and j situation that I mentioned earlier, along with the magnitude, to get the component form in our rectangular situation. Okay, so standard with the brackets, rectangular with the I and j, but this a cosine theta and a sine theta, those give us the horizontal and vertical pieces of our vector. All right, so let's do a couple examples, shall we? All right, we've got in example 5, -3, 2. Now, what I'm going to do here is I'm going to go ahead and draw this vector first, okay? So we're going to come down here. We're going to go from the origin. We are going -3, and we are going up 2, okay? So in other words, our vector will have an initial point at the origin and a terminal point at -3, 2. So now the question is really, how long is this vector? Okay, so that's what we want to determine when we're thinking about finding the magnitude. Let me zoom in a little bit. This should feel familiar from some of our other previous lessons, but to find that length, I can find the horizontal piece and the vertical piece, and then all of a sudden, I've got a right triangle, okay? Now, that means that my a squared plus b squared will give me the c squared, okay? So I'm going to go ahead and I'm actually going to write in, we're going to call this vector u, okay? And so if I want to find the magnitude of vector u, the symbol I use is like this, okay? And that should look familiar. We've looked at that as the modulus of a complex number, or the distance from the complex number to the origin, okay? And the way we find it is exactly the same. We take our a value, we square it, we add it to our b value squared, and then we take the square root of the whole thing because we don't want c squared, we just want c. We do a little arithmetic. We get square root of 9 plus 4. So ultimately, the magnitude of this vector is the square root of 13, okay? All right, so that's the magnitude. Now let's go ahead and find the direction of the angle. So theta equals the inverse tangent of b over a, so 2 over -3. Now this, unfortunately, is not one of our nice unit circle values. So we can use our calculator to find this. But when we type this into our calculator, it tells us the answer's -33.69 degrees, okay? And if I think about my diagram here, I know 0 degrees is here, but -33 would be like here, right? This is -33. That's not what our picture tells us. In fact, our picture tells us it's not -33, but if we added 180 degrees, we would get to our diagram. So we need to be a little bit smarter than the calculator. We need to add 180 because of the quadrant we know it's in, and we will end up with 146.31 degrees. Okay, so if someone asks you the magnitude of your vector, fine, plug it into the Pythagorean theorem. But if someone asks you about your angle, your direction, you really have to make sure that your angle measure, whatever the calculator gives you, matches your diagram, okay? All right, the last piece we're going to do, we're going to go ahead and write the component form of the vector in standard form and in rectangular form, okay? So vector u can be written as √13 cosine 146.31 degrees, comma, √13 sine 146.31. Okay, this is our component form in standard. And then we could also say √13 cosine 146.31 degrees I plus √13 sine 146.31 degrees J. Okay, so all that does is this tells us our horizontal component, and this tells us the vertical component. All right, so our horizontal component and our vertical component. All right, so hopefully that wasn't too bad, but we're going to go ahead and try a second example like it. It's going to involve some fractions, because sometimes even though we have fractions right off the bat, it actually turns out that ultimately it's going to be a little bit nicer for us, okay? All right, let's call this vector v. And if we want to start by finding the magnitude, we're going to get magnitude of v equals the square root of -√3 over 2 squared plus -1/2 squared. We're going to be really careful about our arithmetic here. √3 over 2 squared is going to be 3 over 4. Plus -1/2 squared is going to be 1/4. And those are values I expect that we are able to do without a calculator, okay? So root of, let's see, 3/4 plus 1/4 is 4/4. Now again, we're in pre-calc. I think that we should be able to simplify these, okay? Even though it looks kind of scary. 4 divided by 4 is 1. And so we really get a magnitude of 1. So we have this vector. Sure, though the actual components might look a little gross, but the magnitude is so very nice. It's just 1. Okay. Whereas in example 5, we kind of had the opposite. Nice numbers in the component form, kind of a gross magnitude. Okay. All right, let's find our direction, inverse tangent of, let's see, our b over our a. Now again, looks kind of gross, but I'm choosing these values because knowing these tangent values are actually super helpful for us. We do a little bit of simplification. We end up with 1 over root 3. And we think about where on our unit circle we have this as our tangent. And it turns out we can choose from pi over 6 or 7 pi over 6. Okay, now to choose the right angle, let's draw our picture and make sure that we're matching it to the correct angle choice. Okay. All right, so let's see, square root of 3. If I divide that by 2, I get 0.866. So really my horizontal piece is about 0.866, oops, to the left, and then I'm going half up. So it's going to be super small in here, and that's okay. Oops, negative both times, negative and negative. Okay, so our vector looks so much smaller than the one we had in example 5, but that's okay because this one had a magnitude of root 13, while the other one only has a magnitude of 1. Now, knowing what we know about our unit circle, is this angle pi over 6 or 7 pi over 6? And I hope we say that it's 7 pi over 6 because that is the one that is in quadrant 3, okay? So not pi over 6, but 7 pi over 6. So again, sometimes even if we did this on a calculator, we need to be a little bit smarter than the calculator and figure out how we find those values based on what the picture looks like, okay? All right, last but not least, let's write our v vector in its component forms. And so we end up with 1 cosine 7 pi over 6 and 1 sine 7 pi over 6. Or we can be fancy and say 1 cosine 7 pi over 6i plus 1 sine 7 pi over 6j. All right, so figuring out our components and our magnitude and our direction, going through a couple examples and realizing hopefully this is actually pretty similar to some of the stuff that we've been studying, okay? All right, in our next video, we're going to focus on these kinds of cases. In particular, we're going to focus on situations where the magnitude of that vector always happens to be 1. All right, so come on back for part 4.